Hello everybody, welcome back to High School Tutoring. I'm your host Manny, and today we're going to be talking about equilibrants, which equilibrants are another force vector that can balance a set of other forces acting on an object. So it's kind of like if you have a vector, an equilibrant is something that can kind of counteract it and balance it out. So you see we have this vector here that's facing this way, and the equilibrant is this vector, which is facing the opposite way, which is balancing it out. So it's basically just a line that's completely opposite of the first of like your actual line. And so in our scenarios, we're gonna be looking for multiple like vectors, and we're gonna find the equilibrant. So we're gonna have like something like this. We're gonna have a line that we're gonna find out of these two vectors, and then we gotta find the equilibrant or the opposite. So yeah, we're gonna be using some trigonometry. As you can see, we have our Newton value and we have degrees, so we're gonna have to use SOHCAHTOA and our inverse trig. So yeah, that's kind of it, and we're just gonna now begin. So we have our first problem here, or we have our problem, I mean, and we have to calculate the equilibrant. So we have our vector 1, which is 0.980 newtons at 0 degrees, so straight directly east, and 0.588 newtons at 127 degrees. So these are counting from total from 0 to 360. And okay, and we can begin. Obviously, since we have 0 degrees here, that means that all of this is the x value, so 0.980, and then this y value is going to be 0 because it's directly going across. And yeah, it's just simple enough. So what I'm looking for here is going to be a little bit of more usual stuff. Okay, and now we're going to be looking through the second one. So this second one, now we actually have a degree, and so what I want to do first is subtract 127 by 90 to find just the degrees in the specific quadrant that it's in, which is in the second. So if I take my calculator here, and I don't really need it, but I'm going to solve it anyway, we're going to get about 37 degrees. So that's what we can use to solve for this. So if we go in here, we're going to multiply 0.588 times the cosine of 37 degrees. So let's do that. And now we have our solved value. So I got about 0.696. I'm just gonna do 0.47. So yeah. So we're gonna have our value here. So if we do 0.588 times the cosine of 37, that is equal to 0.67. So oh wait, that would be 0.47, not 67. Oh boy, I'm struggling now. All right, that would be 0.47 newtons as one of our two vectors. And since we subtracted by 90 and didn't subtract 120 or subtract 127 from from 180, we are actually gonna get the west of north value. So we're gonna have west of, or like if this was like our direction, it would be in west of north. So that means that this vector, the cosine, is actually the y. So if you can imagine it, this is kind of what we did. So we did something like this. That we found the angle that was in this side. So this angle here we had was 37. So that's 37 in here. If we had subtracted 127 from 180, we'd have the angle that's in here. So yeah, that's kind of the difference. So we're realistically looking for this resultant, but otherwise the 0.47 will be our y value for this one specifically. And so now we can just do 0.588 times the sine of 37, and now we know that this is going to be our x value. So sine of 37, and that's going to be 0.353 newtons. Oh, 354 newtons. Okay, besides, just ignore me. So now what we're going to do, well, actually, this is going to be negative 0.354, because remember, we're going this way with our x, and it's past the origin value, so it's going to be negative. And yeah, now we know that. So now what we're going to do is we're going to add each of our each of our components. So this would obviously be 0.47. That's going to be simple. And then 0.980 minus 0.354 is equal to 0.626, which is now that we have our components, we can find our hypotenuse of this. So 0.626 squared plus 0.47 squared, and that's gonna be that. And oh well, remember these two are added, so it's not for this one specifically, but it's for our answer one. So we can now do that. So 0.626 squared plus 0.47 squared, and now have that, and then we could do that. Have everything in our thing. We get 0.7 or 0.783. Yeah. So I have that correct. We get 0.783 as our main. So the equilibrant is always the same as the as just the as the original one. So if you've seen this example, it's the same exact line, just flipped. So we're seeing that's the same as that. Those are equal. And since 0.783 is what we got for this line, this is what we're going to have for this line, 0.783. That's going to be the same amount in newtons. And yeah, so we can also find a direction. So if you want to find it, we can use, I'm going to use cosine -1. Since these are both positive, x is going to be our cosine, so that's 0.626 over 0.783. So now, if I just do that math, 0.626 over 0.783, and that's all in parentheses, we should get about 37 degrees. So that is, get about 37 degrees, and since it's going to be drawn like this, it's going to be drawn like that, that means that this is going to be northeast. So now we know this, and actually, we can already solve for this. So what we have to do, since we know that it's northeast, all we have to do, the answer, so I'm just going to make a little box for our equilibrant. So I'm just going to do equi to represent the first four letters. And so we're actually just 37 degrees southwest. So remember, if this is our equilibrant, not drawn to scale, I mean, if this is our our total vector, this will be our equilibrant. And if this is northeast, this has to be southwest. So that's that. Or well, actually, now we can actually make this into a total angle. So we just do 37 plus 180, or the other way around. That's gonna be equal to 7. That's 1 there. That's gonna be 217 degrees. So that's it, really. So we do 217 degrees, and obviously remember our 0.783 newtons, and that is it for our equilibrant. That's all we had to do for this. So yeah. Sometimes you're gonna get 3 vector values, and that's just annoying. But yeah, that's really it for equilibrant, and I hope you guys enjoyed this video and maybe learned something from it, because I do these things just to help other people out, and I hope you guys enjoyed otherwise, and have a good one. Bye.